It turns out that our limit laws also apply to one-sided limits as well. So the one thing I will make note of here is that we just need to be careful with roots, and this is just me saying, hey, you know what, we want to make sure that we're always taking the square root of a positive number. As soon as we start to get into the realm of imaginary numbers, complex numbers, things might get a little bit weird. We're not going to worry about those in this class. We're going to stick to real numbers. So as long as we're dealing with real numbers, all of our one-sided, or all of our limit laws will also apply to one-sided limits here. So here I've got this piecewise defined function f of x, and I'm going to look at the left and right hand limits at -5 and +5, and then use those to help me determine the two-sided limit as well. So we'll start here with a limit as x approaches -5 from the left of f of x. So these might be a little bit tricky here to start off. If you have trouble visualizing, what I might suggest doing is I'm actually just going to draw a little number line over here, and I'm going to say, okay, here's -5, here's +5. So we're looking at 5 from the left-hand side right here. So if I'm talking about 5 from the left-hand side, or -5, excuse me, from the left-hand side, I'm talking about this part of my function right here. I'm talking about numbers on the left, and those types of numbers are all less than -5, right? Think about the numbers that are over here, -6, -7, and so on. Those are all less than 5. So if I want to think about how this function is defined, well, it's defined by 0 here in this case. So no matter what, I'm just, well, if I just try and plug -5 into that part, it's a constant, it's just going to be 0 then. So hey, there we go, there's our limit. Part B, when we go to talk about limit as x approaches -5 from the right-hand side, now I'm talking about these values over here. I'm talking about these values, so think about, say, -4, -3, -2. These values, as long as we're staying close to -5, these values are all greater than -5. This says -5 is less than x, but another way I can say this is that x is greater than -5, and as long as we stay relatively close to -5, we can just consider x is greater than -5 here, which means we're looking at 25 minus x squared here. That's the part of the function that we're going to look at. But one thing we want to make sure of is, we said earlier, we want to be careful with these roots. So what I'm going to do is I'm going to just make sure that my function exists over there on that side of 5. So you might take a number that is greater than -5. So I might take, say, x equals -4, you could take -4.5, -4.9, just something on the right-hand side of -5, and I'm going to plug it into this part of my piecewise defined function right here just to verify that I do in fact have a square root of a positive number, that I'm dealing with real numbers, because otherwise I know that the function won't exist over there, the limit will not exist. So if I look at that, that's radical 25 minus -4 squared. This is radical 25 minus 16, gives me radical 9, gives me 3. And this is really just to make sure that the number inside of our square root, right, this number right here, I just want to make sure it's not a negative. In this case, we had a positive 9, so we're all good. There's nothing really we need to worry about. So when it comes to evaluating this right-hand limit now, I'm simply going to take -5 and plug it into that part of my function. So square root of 25 minus -5 squared, and I'm going to evaluate this. So here I've got radical 25 minus -5 squared is also 25. So I have square root of 0, which is 0. So I have 0 for the left-hand limit, 0 for the right-hand limit. So when I go to talk about the two-sided limit at -5, I can simply say, because the left and the right-hand limit were both 0, this two-sided limit must also be 0. And then I'm going to essentially repeat this process again for +5. So now I'm going to move over to +5. So now, let me change my colors here. You will do this in, how about green right here? So now we're talking about this part, slightly to the left of -5. Actually, let's change to green here too. And again, you may want to just verify that our function exists close to 5. And you think about if you were to plug in 4, right, I would get the same thing that we did up here. So if I said x equals 4, just to verify again that our function exists close to 5, you would have radical 25 minus 4 squared, radical 25 minus 16. We're going to end up with the same thing that we did earlier. So you can keep going with that if you want. But as long as we know, okay, the inside part of our radical is going to be positive, which means we can evaluate this left-hand limit here by just taking 5 and plugging this in. So 25 minus 5 squared. Here I've got radical 25 minus 25 again, which is square root of 0, which is 0. So okay, we have the left-hand limit. Part E is asking for the right-hand limit. So now for the right-hand limit, let's do this in purple, how about that? For the right-hand limit, I'm talking about these numbers over here, numbers that are greater than 5. So right numbers over here would be 6, 7, 8, and so on. Those numbers are all greater than or equal to 5, so I'm thinking about this part of my function right here. So I'm going to take 5, plug it into 3x, so this will be 3 times positive 5 will give me 15. Part F should follow fairly naturally then, because I can just look at parts D and E. So the left-hand limit was 0, the right-hand limit was 15. So the two one-sided limits in this case do not agree. They're not the same number, which means that the two-sided limit then does not exist or is undefined here. There's no work to show for that. I've already shown my work in parts D and E. So let's take a look at one more example here in this video, just because I really want to highlight roots and how we deal with those. So here in this example, I've got a function f of x with a radical in the denominator. I want to look at limit as x approaches 2 from the left, 2 from the right, and then the two-sided limit at 2. So here in this case, you might start by saying, well, let's just jump into the two-sided limit and see if we can't just figure this out here. Let's say of f of x here. I don't want to write the whole thing out. So this will be 2 to the third power minus 6 times 2 squared plus 8 times 2 divided by radical 2 minus 2. So I've got 8 minus here 2 squared would be 4 times 6 would be minus 24 plus 16 over square root of 0. I'm getting a little bit nervous here at this point. 0 over 0. Oh shoot, we've got this indeterminate form here again. So this is kind of one of the reasons why we needed to look at the two one-sided limits, because we have this indeterminate form. So the thing I'm most worried about is this denominator, and where in particular x minus 2 is going to be positive here. I want to make sure that that inside part is positive, because I know on the other side, if I end up with an imaginary number, that limit's just not going to exist. It doesn't exist for real numbers. So maybe let's try this. I'm going to take just the part that's inside of the square root. So not the square root itself, just the part that's inside of the square root, x minus 2. I'm going to go ahead and find the domain of that function. I'm going to find out where is this function positive. We know it can't be 0 because then we're dividing by 0. We run into the same problem that we just did up here. So I'm going to say, where is this function greater than 0? And I have this little inequality that I can solve now. So here I have x is greater than 2 if I add 2 to both sides. So here we're really talking about the right-hand side of 2. So that's where it's positive. So what does that mean? Let's talk about the other side first, and then we'll come back and talk about the right side here. So that means that for the left-hand side, and you can even just verify for yourself, right? If I chose a number that was less than 2, so I'm going to pick 1 here in this case, and I plugged it into this denominator right here. I'm just going to look at that denominator. There I'd have square root 1 minus 2. This is square root of negative 1. That's imaginary. That's not a real number, and we don't want to deal with that. So what that means for us is that f of x does not exist, does not exist for x is less than or equal to 2. Now I'm going to say or equal to. Whenever we have 0 over 0, that function does not exist at that x value. So it does not exist for x is less than or equal to 2. So what that means, if the function itself doesn't exist, that then means that the limit as x approaches 2 of f of x also does not exist. Because if the function doesn't exist, it doesn't really make sense for me to talk about the limit of that function. So I can't say anything else. So the limit as x approaches 2 for x less than. So we're only talking about, I made a mistake here, we're only talking about the left-hand side here. Because the right-hand side, we set up here, hey, if you're on the right-hand side of this function, then your function exists. That's something that we can work with. So if I wanted to work with this function, if I wanted to talk about the limit as x approaches 2 from the right-hand side of my function f of x here, I'm just going to see, well, what can I do with that function? So limit as x approaches 2 from the right, and let me go make sure I copy this function down correctly. X cubed minus 6x squared plus 8x. X cubed minus 6x squared plus 8x divided by radical x minus 2. So if you remember back to the last video, we said, hey, if you end up with an indeterminate form, if you end up with 0 over 0, you might want to go back, you might want to try factoring, you might want to try the conjugate, things like that. There's a few different ways that you could go about this. How I think I would... You know what I think I would do actually here? I was going to factor, but now that I look at it, I think it'd actually be a lot easier to multiply by... Oh, you know what? Oh, I do have to factor. I was being clever here. Thought I would get away with it, but not. Okay. So I'm going to factor that numerator. My apologies there. I was just thinking out loud, trying to be too smart. Limit as x approaches 2 from the right. First of all, that numerator, I can factor out an x, so let's start there. X squared minus 6x plus 8 divided by square root of x minus 2. And then I need two numbers which multiply to be a positive 8, add to be a negative 6. That would be, let's see, limit as x approaches 2 from the right. X, I should have, x minus 2 and x minus 4 all over radical x minus 2. Now, how you want to continue for the rest of this problem is up to you, and I'm kind of running out of room here. Let me actually just pick up right here. So let's say limit as x approaches 2 from the right. I've got x times x minus 2 times x minus 4 over radical x minus 2. Now, there's a few different ways. The way I actually was thinking about it earlier as I worked through this problem, square roots, remember I said earlier, hey, square root of x, that's really equal to x to the 1/2 power. So I could rewrite this as x minus 2 raised to the 1/2 power. And then you could actually cancel this guy and this guy. My guess is most of us probably wouldn't recognize that. It's just not something that we're too familiar with quite yet. So I'm going to leave that square root there, just for now. And maybe you'd say, okay, well, I'm going to multiply by square root x minus 2 over square root of x minus 2. We're going to get rid of that radical here. So I'm left with a limit as x approaches 2 from the right. In my numerator, I'll have x times x minus 2 times x minus 4 times square root of x minus 2 all over, when I multiply square root x minus 2 times square root of x minus 2, square roots cancel, I'm just left with x minus 2. And then, hey, look at this. We can cancel out our factor of x minus 2. There's nothing to stop me now from taking 2 and plugging it into whatever's left over here. So I would be left with 2 times 2 minus 4 times square root 2 minus 2, which here I've got 2 times negative 2 times square root of 0. Let's see, negative 4 times 0 gives me 0. So this is my right-hand limit. If I wanted to summarize my right-hand limit, I would say limit as x approaches 2 from the right of f of x is equal to 0. So we have the left-hand limit. That did not exist because the function didn't exist over there. We were dealing with imaginary numbers. On the right-hand side, it's 0. For the two-sided limit, I'm just going to look at the value of these two limits. One does not exist, the other is 0. Those two limits are not the same. So when it comes time to talk about the two-sided limit here, I'm going to say, well, in this case, the limit as x approaches 2 of f of x does not exist because the two one-sided limits are not the same. So just be very careful when you're working with radicals. You'll want to think about the domain of your function. You'll want to think about where does your function exist so that you can more easily talk about the limits. And you can kind of understand, okay, where does your function exist? So that means that can help you determine where your limit exists.